Welcome to this explainer. Okay, let's dive into this. If you're a future construction management professional, you've probably heard the term smart city thrown around, well, constantly. It's everywhere. But what does it actually mean for the people who literally have to build, deliver, and maintain these systems? Today, we're going to strip away all that marketing hype and look at the real physical fundamentals of smart cities.
So here's our syllabus for today. We'll start with what is a smart city, then move to separating myth from reality, explore the 5 city layers, cover evaluating capabilities, look at some global examples, and finally wrap up with the CM lens. We are going to start with a high-level overview and gradually zoom way into the rigorous details required to actually build and maintain these things.
All right, Section 1, what is a smart city? Defining the built environment problem. Let's move completely past the buzzwords here and get into some actionable definitions. See, a smart city isn't just a software platform or a bunch of shiny new apps. As Japan's Society 5.0 concept frames it, it's a coordinated built environment system that tightly integrates cyberspace and physical space. And why? To solve actual social problems and improve outcomes for people. For those of us in construction management, this is, at its core, a built environment delivery problem. Smart services depend heavily on physical reality. We're talking roads, transit stations, power grids, fiber networks, maintenance crews, and procurement rules. Because of that, I want you to treat this like a student field note to keep in mind throughout our explainer today. Whenever a city or a developer calls a project smart, you need to stop and ask, okay, smart for whom? What actual community problem is being solved here? What physical system is going to enable this digital tool? And, absolutely crucial, who owns the data being collected? We really need to keep this critical, people-centered perspective sharp.
Moving right along to Section 2, separating myth from reality, common misunderstandings. Let's do a rapid-fire myth-busting session to clear away some of those amateur assumptions that can absolutely tank a project.
Okay, myth number 1. A smart city is just a collection of a ton of sensors. The reality, sensors are entirely useless unless they support concrete decisions and daily operations. For a construction manager, this means you can't just slap a sensor on a wall and call it a day. You have to meticulously plan the data flows, the physical power supply, the mounting hardware, the cybersecurity protocols, and honestly, how the facility team will actually reach the thing to fix it.
Myth number 2, a smart city relies on a single vendor platform to run everything. The reality here is that a durable smart city demands interoperability. You absolutely need open standards, open APIs, and strong data governance. If you don't mandate this during procurement, you are going to fall into the trap of proprietary vendor lock-in. That's where one single company controls all your infrastructure, and let me tell you, lifecycle support becomes a total nightmare.
And myth number 3, a smart city is this futuristic sci-fi concept full of flying cars and holograms. Let's bring this back to Earth. Meaningful smart systems exist today, right now. Transit cards seamlessly moving millions of people, building automation systems optimizing energy use, emergency flood alerts, GIS mapping. Real operational systems matter so much more than flashy futuristic demos. Let's look at Section 3, the 5 city layers, visualizing the architecture. Now that we know what a smart city isn't, let's look at what it actually is by visualizing its core architecture. And this brilliantly illustrates how performance is built in layers. A true smart city is a coordinated urban system. It links community needs to physical infrastructure, then connects that to a digital layer, which is overseen by governance, and all of that finally leads to measurable outcomes. It's like a giant puzzle. If you have weakness in any single layer, say a digital app that isn't connected to durable physical infrastructure or tech that's deployed without community trust, it severely limits the long-term value of the entire project.
Let's quickly step through this progression. Step 1 is identifying the problem, like traffic congestion or a disaster risk. Step 2 is building the physical systems, the actual streets and utilities. Step 3 integrates the digital layer, so sensors and data standards. Step 4 establishes governance, rules for privacy and funding. And Step 5 measures outcomes. This creates what we call a continuous data-to-action loop. Physical infrastructure and digital tools literally must combine under strict governance to solve actual local problems.
Which brings us to Section 4, evaluating true smart capabilities, using the maturity matrix. We are now shifting into a rigorous, professional deep dive. How do you actually evaluate whether a city has meaningful capabilities or if it just has a really good marketing team? Now, what's really interesting about this slide is the stark difference between isolated tech pilots and a truly mature system.
Look at the criteria for an emerging score 1 versus a mature score 5. An emerging city might just run tech pilots with no clear goals, trapped in vendor silos, managing physical assets completely separately from digital ones. But a mature score 5 city? Outcomes are actively measured and used to improve policy. They use open standards. And crucially for us as CMOs, lifecycle asset management deeply connects design and construction directly with operations, maintenance, and digital twins. But here is a quick instructor's caution for you. Please don't pretend any smart city is perfect across every single dimension. A city might score a 5 in mobility, but maybe a 2 in energy resilience. You always have to look for the operational realities on the ground and be prepared to explain the trade-offs.
All right, Section 5, Global Smart City Examples, Learning from the Field. Let's transition to some real-world applications as case studies, which really prove that different local problems demand completely different smart strategies. Let's start with some lessons from Japan, where the approaches are just incredibly diverse. You have Kashiwanoha, which ties smart development directly to transit-oriented planning and university innovation. Then, Fujisawa Sustainable Smart Town takes a completely different route, focusing entirely on a resident's daily life cycle, planning housing, energy, and community facilities as one cohesive system. Meanwhile, Aizu Wakamatsu proves that smart cities aren't just for shiny megacities. They can brilliantly respond to regional challenges, like aging populations and healthcare delivery.
And contrasting these with other global examples, we see even more variety. Singapore, for instance, employs a top-down, whole-of-nation digital strategy requiring just massive government coordination. On the flip side of that, Amsterdam thrives on networks of decentralized open innovation projects focused on the circular economy. And Copenhagen? They use pilot projects as municipal living labs, which are fantastic for testing, but they must eventually prove they can actually scale into normal city operations and budgets.
Finally, Section 6, the construction management lens, your role in the smart city. This is the climax of our explainer. We've talked about the theory, we've seen the global examples. Now, let's talk directly about your specific responsibilities.
So, the crucial point is how you manage the project phases. In planning, you absolutely must justify the technology with measurable outcomes. If you don't do that, you're just building a useless technology demonstration. In design, you ensure digital systems securely connect to physical utilities. In procurement, and please pay close attention here, you must secure data ownership and software warranties to avoid high lifecycle costs and vendor lock-in. If you ignore this, the project has zero lasting value. None.
Moving into the later phases. During construction, your job is coordinating device mounting, network pathways, and power supplies to prevent broken data links and massive security gaps. In handover, you must deliver proper training, asset data, and manuals. Let me be clear, if you have a poor handover, facility staff literally cannot operate the systems you built. Finally, in operations, outcomes must be measured post-opening to prove the value and adapt to the city over time.
Let me reinforce the ultimate reality check for any construction manager out there. A smart building or a smart district that cannot be maintained is not truly smart. Technology without maintenance and without highly durable physical infrastructure is entirely useless. Your job, above all, is to ensure that both the physical and the digital infrastructure survive their entire life cycle.
Which leaves us with this final, vital question as you head out into your careers. How can you, as construction managers, help deliver and operate urban systems that are smarter, safer, more sustainable, more inclusive, and more resilient? You are the ones building the future, layer by physical layer. Think about it. Thank you so much for joining me for this explainer.